The engineering product development pillar is not only about equipping engineering skills and knowledge, but we also teach design thinking and enable students to build better products to solve complex engineering problems. Let me now invite on stage our Head of Engineering Product and Development Pillar, Professor Lo Hong Yi, and with her, Assistant Professor Nagarajan Raghavan. Joining them, we have Dr. Gabriel Tuzinski from the Humanities, Arts, and Social Sciences cluster to share how HAS is integrated within the curriculum. And with us, our senior student, Kusharagi Jain, will be moderating this panel.
Thank you. Good afternoon. Welcome to the EPD sessions. This afternoon, we're going to give a very quick overview of EPD, and then we're going to continue on with a panel-like discussions. We will also take questions both from the live audience as well as the Zoom audience. To help you to get to know a little bit about EPD, and I'm sure you have brochure in your hand, we want to talk about what's an engineering degree supposed to be or should be in the 21st centuries. And what better place to find the answers than to look at the real world? What does an engineering profession need in the 21st centuries? For those of you who had heard the earlier presentation by our president, we are very well aware that in the real world, in the 21st centuries, the challenges are complex. The technology that we know today may become obsolete by the time you graduate. These problems, these complex problems, cannot be solved by a single discipline. So our answers to what an engineering degree should be in the 21st century is engineering product development pillar. We like to refer to it as EPD. Behind EPD is a team of educators that come from various engineering disciplines. Mechanical engineering, electrical engineering. I'm a material science engineer by training. Together, we co-created engineering courses and program that helps to bring out and to help to connect the different engineering disciplines. Many of these experts are actually top scientists and innovators in their own field. Let me give you a flavor of the courses in engineering product development pillar. One of them is the constant experiences in applying fundamental knowledge to solve complex problems. And by that, I'm not referring to paper-based problem sets. Our students apply the knowledge they learn, like in this case, circuit and electronics, in innovating or solving a challenging problem in energy harvesting. In another flavor of EPD courses, we put human factors, human constraints, human interests into engineering equations. One of our signature, our students hone these skills in our signature course called Engineering Design Innovation. So let's talk about innovation a little bit more then. Here, I share two quotes from a recent book that I came across. It's a book written by two professors from Harvard University. One of them says, innovation people routinely generate many more possibilities than average. Well, the question is, how many is good enough? How many is many? I encourage you to Google search these questions, or better yet, use ChatGPT. But let me give you a real-world answers. Sir James Dyson, one of the icon of innovator in the 21st century, has his own experience to share. He had experimented with more than 5,000 prototypes to come up with the first backless vacuum cleaner. So for those of you who had a chance to join the Sumo workshop this morning, you would have experienced our Dyson SUTD Innovation Studio. It gives you a flavor of how courses are run in EPD. That's not it. Whatever that I've shared so far, it's still not sufficient to be for engineering degree in the 21st century. And for the next aspect of it, I need my colleague Gabriel to help.
Thanks very much. And let me add my welcome to everybody today. I hope you're all enjoying your visit. I just wanted to quickly share my own thoughts about what I think the role of the Humanities, Arts, and Social Science interdisciplinary cluster is for an SUTD design and engineering education, especially as it relates to the EPD pillar. And I really think what HAAS is about is getting engineering students to build pretty strong connections between design practices, the products that we make or the technologies that we produce, and society itself. It might seem like engineering or design are just about figuring out how something works from a technological or a functional standpoint. And that sort of approach can kind of seem to be self-contained. It can look something like the picture that you see here, the sphere, right? Where these things are seen to just happen in the vacuum of a studio or a laboratory space, right? But what HAAS tries to do is try to open design back out into the real world, or maybe I should say bring the world back into the studio a little bit. And when you do this, a whole lot of other questions actually starts to pop up. Beyond the how does it work question. That has to do with how humans work, how real people work. What are their needs, what are their desires, what are their aspirations, their situations, their motivations, what is the structure of their everyday lives, how do they work, how do they play, how do they make ends meet. And then on the other side of things, we can ask the question about how a design, a technology might actually impact the world once it's kind of released into the wild, as it were. So what we really want to do is sort of sensitize future designers, our own students, to think about the broader social contexts that inform their work and actually to be able to think critically and to communicate clearly about these in their design work. So I think HAAS really kind of switches the question a little bit. We contribute less to the question of how something works technically than why it works socially. That is, why does a particular design make an impact for specific people and not for others, right? Or for that matter, why does a product fail completely? In order to do this well, I think we have to understand people. We have to understand others. Designers like to call this building empathy with users, right? We have to make connections to the ways that real people live, to grasp the full range of people's emotional lives, and also anticipate how a new product's function can contribute to and augment their existing lifestyles. So, in other words, to put it short, we can only really design well if we understand humanity and all of its depth, all of its complexity, and really all of its beauty, too. So I think that's what HAAS brings to the table for EPD.
Gabriel, can I? Yes. So that actually, in a nutshell, a part of design thinking. So the engineering product development experience emphasizes, or what we see as an engineering degree of the 21st century, the need to bring out in you collaborative nature through design thinking skills, through your interdisciplinary knowledge that you will learn in EPD, hands-on learning to solve complex problems over and over again. So here's a little questions for you to find out. On average, what do you think? How many prototypes does EPD students go through by the time they graduate? So before we end, we move on to the panel discussion. I thought I'd share a couple more slides that often a question that often comes to us. What kind of job do our graduates go to? Actually, I forgot that I wanted to share this slide about EPD that has 7 specialized tracks. So a degree in engineering product development pillar gives you an option to specialize in electrical engineering, mechanical engineering, healthcare, robotic, computer engineering, but very uniquely beyond Industry 4.0, also very uniquely a self-directed track that allows you the options to design your undergraduate program. So here's the slide that I was going to share on where do our graduates find jobs. Essentially, every industry that has product and product development interests, right? It can range from aviation industries, GV aviation, And airplanes is a physical product. It could range from an EV vehicles. A vehicle is a physical product. MedTech industries, medical devices are physical product, as well as obviously some of our kind of government organization like Defense Science Office. But every year, a certain percentage of our students continue to pursue postgraduate studies. And every year, about 4% of our graduates go on to start up companies at the point of graduation. And I want to share these two alumni. Chihao and Dexter are from the class of 2015 and 2016, if I remember correctly. They both went through postgraduate studies as well as startup companies. So I shall stop here so that we have enough time for the panel discussion. Over to you, Kush.
Thank you, Professor. We will now be opening the panel to all of you. The viewers here in the auditorium, please feel free to ask questions. There are mics located on the sides. For our online viewers, you may submit a few questions. And actually, we already have a few, some of which I believe are quite relevant to what we have here. Prof. Naga, this one is for you, actually. Given all the trends and hype surrounding artificial intelligence nowadays, what is the role that EPD graduates can play in the field of AI? You know, how does knowledge in EPD help people in the field of AI?
Oh, yeah, thanks. I'm Naga. Nice to meet you all. Yeah, artificial intelligence is, there's a lot of, people think that it's all about software and algorithms and mathematics behind it. But end of the day, when you have these AI algorithms, that have to be part of a products and systems that you make, you still need the hardware to support you. You need the logic devices, you need the memory devices, you need all the microprocessors to work, to implement and get these algorithms to work on the hardware itself. So I would say that EPD, where hardware is one of our key focus, is kind of at the heart of how AI can actually permeate into different products and systems. And if you look at all the data centers that are doing all the cloud computing for you these days, these data centers are all about these nano-electronic devices that form the heart of the data centers. And if you look at these data centers these days, the amount of carbon emissions that's coming out of it is even more than the whole aviation industry put together these days. And therefore, there's a lot of push towards having computing and AI on the edge, which means you have devices in an autonomous vehicle or in an IoT sensor that does computing on the edge there itself. And again, for such applications, EPD gives you these skill sets of how you can design circuits and devices that can actually be implemented in the edge for more energy efficient computing. So I would say that EPD is very much at the core of AI. So it's in a way, EPD and hardware is kind of the body and software as the soul. So you kind of need both of them to get AI to really make a difference in the society in the future. Yeah.
Thank you, Professor. We just got a new question. How is EPD different from DAI? Both majors seem quite similar, with DAI having more specificity. Prof. Lo, would you like to take this one?
Absolutely, sure. The primary difference between DAI and EPD is, to me, obviously, it's the EPD having a core focus on engineering discipline. So the core courses in EPDs that give you the foundation in mechanical engineering and electrical engineering is one of the main differentiation from DAI.
Thank you. Maybe I'll add on to that a little bit from what I know as a student. DAI is more about how you can apply AI into design, whereas EPD tends to focus a little bit more on the actual hardware side of things, or how you can go about integrating a lot of these physical components into it. So there are different focuses. Admittedly, there are overlaps, but DAI tends to focus a little bit more on AI. We have another question here asking about what are the highlights of the EPD experience, and maybe I'll take this one. As a student, I would say that the very first thing you do when you enter EPD in the second year of SUTD is this course called 30007, Engineering, Design, Innovation. And that is a term-long project where you work with engineers from various disciplines. You'll probably have an electrical guy on your team, a mechanical guy on your team, and all of you work together on this one term-long project. Actually, outside on the booths, you'll see a few of our past projects that have been put up by students. And usually these projects are the first exposure to making you feel like, wow, you can feel like a real engineer working in a real team to produce something that's functional and useful for society. Sometimes there's different kinds of themes, and usually it'll be something from sustainability to safety, things of that sort. You get to experience these kinds of things. You spend a lot of nights in the Fab Lab working with your team, tinkering away at your machines, and I think that's really one of the core highlights of what makes EPD so valuable. You get to see a little bit of everything in EPD.
May I add to Kush's experiences by bringing out that many of these courses have industries partner involved. 3007, for example, at the end of the course, students get to showcase and display as well as pitch their prototypes to industry members who come to provide critiques from an industry perspective. So that's also one other characteristic of EPD courses.
If there are any other questions, please feel free to send them. We have a few more from our online audience. Could you tell us a little bit about how engineering skills in EPD could be applied to Haas projects? And maybe Professor Gabriel, you could take this one.
Yeah, I think the question could be framed two ways, kind of as a two-way street in some ways, because Haas skills also get reframed or reworked in EPD projects as well. But obviously Haas is an interdisciplinary cluster, and we actually serve the entire student body. So we've got students from all the different pillars in our classroom. And so our assignments, our assessment items actually have to be broad enough to be able to accommodate all of the different pillar interests. That said, I think there are some ways that each of the skill sets of each of the pillars kind of get incorporated into certain projects. For my own, I included a couple examples in one of my slides of student projects that were for a speculative design project, or sorry, a speculative redesign project of a design that the students had determined had failed in some way for a social or historical reason. And so a couple of the groups actually ended up doing a very kind of EPD sort of focused project by redesigning an implement that actually would fit into a trash disposal bin that would actually do the sorting for people. So what they were doing was actually looking at how people's actual behavior worked, that people were not really willing to actually do the recycling sorting themselves, and sort of outsourcing that sorting to both scanner technologies and color recognition technologies. So that's one way that these things can kind of be implemented.
Thank you, Professor. There's another question asking, since the majors are overlapping in some ways, does SUTD allow students to take double majors? Unfortunately, no. However, you can take minors in other pillars. For example, if you're an EPD student, but you have a little bit of interest in software, you can certainly take up a CS minor to add on to your experience here at EPD. Similarly, there's a few other different minors from each of the various pillars. And in addition to that, there are also Haas minors. If you're interested in either the humanities or the social sciences, you can also hone in on that. I personally am a digital humanities minor student, and it allows you to explore a new range of interests that might not be fit into the traditional degree program. Any further questions? If not, we have one more, and I believe, Prof. Lo, you can take this one. What kinds of skills are unique to the EPD curriculum that other places might not have?
And I thought that one slide that kind of summarized the unique skills that are from, when we design a EPD curriculum, we had in mind that those skills are absolutely important for the engineering profession in the 21st century. The ability to connect knowledge from different engineering disciplines, the ability to collaborate to do that, and to apply design thinking, and not to mention digital skills and hands-on skills. We can't say enough about the importance of, until you actually put your idea into practice, you don't know what you did not see. You don't know what might not work. So those skills are are skills that students go through repeatedly over multiple courses throughout the years in EPD.
I think I'd like to add another thing on top of that is, as a student, sometimes you come into university expecting one thing, oh, this is what I'm interested in. But the beauty of EPD is because it stretches across multiple different disciplines and is it basically an engineering degree without walls, you can find things that might be very interesting to you that you probably didn't know about before. And this is one of the big things about EPD, that being able to explore and figure out what you want to do is a very open-ended curriculum as well. So there's always something for someone here. We have a few more questions over here. Could you tell us about some interesting sectors that the alumni have gone into? Prof. Naga, perhaps you have.
Oh, yes. I think given the diverse disciplines that EPD covers, I think our graduates have been very successful in the semiconductor industry, aerospace, robotics, automation, IoT, manufacturing, operations, chemical, pharmaceutical industries, and many other. And many of our graduates are also working in GovTech and many other national organizations at DSO and DSTA as well. So we got a very wide spectrum of industries which are very keen to work with us, work with our graduates. Yeah.
Thank you. There's a question asking, I am very bad at math and physics. Can I still join EPD? And the answer is yes, I am also very bad at physics, but don't worry, you are not the only person. And being a small class size means that you can get a lot of help. And most of these things come with practice. Admittedly, you will struggle a little bit at times here and there, but don't worry, there's plenty of things in our freshman common year. And along the way, you will pick up things and it'll get easier over time. So it is definitely doable. Don't worry, if you're intimidated by math and physics, it will still be there, but it will be easier along the way. Everybody here has a communal spirit to help each other out. So you can always ask your friends for help. We have another question asking, what personal attributes and qualities does EPD look out for? Prof. Loh.
I like to say that if you believe that coming to the university is for you to relearn, to turn the switch around on how you have been learning, and be very willing to learn across discipline, right? That's our signature, right? We hope that your students, for example, if you are interested, I want to be an expert only in electrical engineering, then perhaps EPD is not the right education program. So we hope students who believe in the value in interdisciplinary learning, be very willing to want to connect the dots of different disciplines, be very willing to want to actually prove that what I learned on the theory can work in my prototype. So that's kind of, I would say in a nutshell, the kind of student we hope to come to EPD.
Thank you. We have a new question. How similar is EPD to a design engineering degree? And I think that you might have to take this one.
So I think the difference, I think what is the heart of EPD is design thinking is weaved into our courses. So it's when you're given open-ended problems. So many of our courses have open-ended design problems where the students are encouraged to first do a research on the topic, like what is the real need of what is the problem, what is the need, what kind of people are going to use it, what are the what are the existing pain points of existing solutions in the market. And they kind of empathize with the users, find out what the real problems are, and then design solutions that cater to the problem. So basically, this process of design where you think of, so the main motto we tell our students is we are not the end users of our own products. You're designing something for somebody else. So you got to put yourself in another person's shoe, understand what pain points they have, and then design a solution that really caters to their needs. So that's basically how we inculcate the societal aspect of designing products for society, and that's something very unique that EPD offers, and that's kind of part of our DNA in most of the courses that we offer as well. Yeah.
Thank you, Professor. We are coming to the end of the time for this session, so unfortunately, we won't be able to take any more questions after this. However, if you're still curious, you want to learn more, you can always find our fellow student helpers outside at the EPD booth in Campus Center. And with that, that will be all for our panel. Thank you, professors, for joining us, and thank you, audience, both here and online, for attending. Have a nice day.
Thank you.
Thank you.
Thanks.
Please go ask the students, EPD student out there, how many number of prototypes they will go through in their 3 years here in EPD.